Now the question is how to draw the Mohr circle, how to find out the coordinate of centroid, what is the radius of Mohr circle, and what exactly the Mohr circle represent. What information we can draw from the Mohr circle. So first of all, for Mohr circle you have to understand the sign convention. For this one, we'll consider here the state of stress as shown in the figure. Sigma x and sigma y are the normal stresses and tau xy are the shear stresses. The given value of sigma x and sigma y is positive as well as tau xy is also positive as per the state of stress is considered. But for Mohr circle, we have different sign convention. There is no change in the sign convention of a normal stress, but the sign convention of the shear stress will slightly change. So Mohr circle is drawn basically with the two axes, one is the sigma axis and one is the shear stress axis. All the normal stresses we have to plot on the horizontal axis that equal to sigma, and the shear stress you have to plot on vertical axis that is the y axis. In this case, the value of sigma x and sigma y, the value of sigma x and the value of sigma y are taken as positive if they are in tension. Naturally, when they are in compression, you have to take it negative value. Secondly, the value of tau xy is positive if clockwise. Now, what is the meaning of clockwise? Suppose you consider this face is perpendicular to the x-axis. So this one is a positive x face, so we'll call it as x face, and this one is a representation of a shear stress right now. About the center is at point O. If this shear stress will rotate in an anti-clockwise, will taken as negative value. So right now the rotation of the shear stress about the point O will be anti-clockwise. So just see the right face here, which one is the x face, and on this one we have shear stress is acting vertically upward. If you check the rotation of the shear stress about point O, it will be anti-clockwise. If the rotation of the shear stress about point O is anti-clockwise, then this value of tau xy you have to take as a negative value, and that you have to plot below the sigma axis. So this axis will be same as equal to tau axis, but this one is negative. So this rotation is anti-clockwise rotation, whereas this rotation will be clockwise rotation. This side we have to use positive sigma and this side you have to use negative sigma. Now consider here the y face here on which the shear stress is rightward. So we have y face here, and this time we have shear stress is rightward. If you check the rotation of the shear stress about the point O, it will be clockwise, and this value of the clockwise rotation will be taken as positive value. So if you have a clockwise, then the shear stress is taken as positive value, and if the shear stress is rotating in an anti-clockwise direction, that is for x phase, the shear stress will make anti-clockwise rotation, that will be taken as a negative value. So the sign convention for normal stress is positive if it is in tension. Positive value you have to plot on the right hand side, and if it is compression, then you have to plot on the negative horizontal axis. For the shear stress, if the shear stress on any face, I am not saying the x phase and y phase, but I am referring with reference to this figure. Therefore my shear stress is acting upward. If it is acting upward and you take a rotation of the shear stress about the O, then we observe the rotation is counterclockwise. If the rotation is counterclockwise, you have to take is negative value. And for y phase, that is this phase here, the shear stress acting rightward. So if we take a rotation of a shear stress about point O, then the rotation will be clockwise, and clockwise value you have to take it positive. So these are the sign conventions are used in the case of Mohr circle. Now we'll construct here a Mohr circle. So this one is positive value of sigma, this one is negative value of sigma. Y-axis represent the positive value of the shear stress, and the negative y-axis represent the negative shear stress. Now you can read here what is the coordinate of x phase and what is the coordinate of y phase. The coordinate of x phase, the x coordinate will be same as equal to positive value of sigma x, and the y coordinate is negative of shear stress tau xy, as well as the y coordinate will be the positive value of a normal stress. So x coordinate means normal stress and y coordinates means shear. So normal stress here is positive value, so you have to plot it on the positive of normal axis, And the shear stress this time is a positive quantity. Positive quantity you have to show on positive y-axis. So you have to treat this value as a positive tau xy. Now right now we don't know this value, so let's temporarily assume that this value is equal to sigma x, and this value represent here the value of sigma y. And one value of negative tau xy we'll plot here on the negative of x-axis. So this one is minus tau xy. So this minus tau xy and plus sigma x will be our x coordinate, that is the x phase. Similarly, sigma y and positive value of tau xy. So positive value of tau xy, that is this point, will be our y phase. So these are the coordinate you can locate, that is the x phase coordinate will be below the sigma axis and the y phase coordinate will be above the sigma axis. So two phases you have to mark first, the x phase and y phase. This time the value of sigma x and tau xy, and the second value you have to take as sigma y tau xy. This value of tau xy you have to take as negative value, and therefore it is plotted below the sigma axis, that is along the negative of y-axis, and this value of tau xy you have to take the positive value. Why this is positive and negative? I hope this concept is clear. For x phase, the rotation of tau xy is anticlockwise. Anticlockwise is taken as negative, and for y phase, the value of shear stress will going to rotate about the point O in a clockwise sense, therefore taken as positive. Remember here, our whole discussion is for this state of a stress. As the value of the sigma x and sigma y and their direction of tau xy will change, entire concept will change, but this idea will remain same, that is mark the value of x phase, mark the value of y phase. Once you obtain the coordinate of the x and y and you are successfully located on the Mohr circle coordinate system, that is sigma and the tau axis, then you have to join the 2 points x and y. Step number 2 says that join the value of x and y, and let's find the intersection of this line joining x and y with origin, and this point we labeled as the center of the Mohr circle. Once you find the center O, that is the intersection of x and y axis with sigma, then you have to take the center as O and you have to take the radius equal to either OX or either OY. So we have radius equal to OX or either OY, and then you have to draw the full circle, that will be called as Mohr circle. So with O at the center and XY as the diameter, you have to draw the full circle. Now you have to record the value from this Mohr circle on the sigma axis and on shear stress axis. This Mohr circle will intersect at this point. Let's call this point equal to C, and corresponding stress you have to measure from the origin, and that will be the normal stress, but will be the maximum normal stress. At point C, whatever the value of sigma you can read from origin, that will be called as the maximum normal stress. So in this equation we have sigma max is same as equal to the distance AC is called the maximum principal stress. And if you mark here another point, that is point D, and you measure the distance AD, it will be called as the minimum principal stress. So very quickly we can calculate the value of maximum principal stress and the minimum principal stress using the concept of Mohr circle. So to find out the value of the maximum shear, I will draw the tangent here from the Mohr circle on tau axis. So this one is a tangent, and corresponding value you can read on the shear stress axis, that will be the maximum value of the shear stress. So let's call this point equal to E. In that case we have tau max will be equal to the distance OE, which is same as equal to the radius R. One value of the shear stress will be negative, so this one is minus tau max, but in fact here, since we are taking the square of the shear stress, it doesn't matter what is the value of tau max, whether plus or minus. While finding the value of the principal normal stress and the shear stress, we always take a square, so whether tau xy is positive or negative, it doesn't matter. So the negative value of the tau max will be same as distance O to F, which one is again a radius. So radius of Mohr circle always give you the maximum shear stress. Where this circle intersects rightmost side, that will give you the value of the maximum principal stress, and where it will intersect nearer to the origin, that will give you minimum principal stress. This time the entire Mohr circle is on the right hand side, but this is not true. This concept can be explained by very well by taking the suitable examples. And the position of O, that is the coordinate of O, we can obtain is equal to sigma x plus sigma y divided by 2. So using the sigma x plus sigma y by 2, we can find out the coordinate of center, and the radius is same as equal to the maximum shear. It means that we have maximum shear, which is given as sigma x minus sigma y by 2 whole square, plus we have tau x y square. So this is nothing but our the formula for sigma max. In the case of sigma max, we are using sigma x plus sigma y divided by 2, plus we have under root of this value, that is sigma x minus sigma y divided by 2 whole square, plus we have tau x y whole square, and everything in the under root sign. This value we'll call it as sigma average. So we have sigma average plus tau max will give you maximum value of. So up till here, this value is called as the average shear stress, and this value is same as the radius r. So sigma average plus radius r, we can calculate the maximum shear stress. Similarly, we can calculate the minimum shear stress will be equal to sigma average minus tau max. So sigma average is here, and then we'll return back that equal to the value of tau max. Then from the distance AD represent here the minimum value of the normal stress, that is sigma minimum. I will take here one example how to draw the Mohr circle. For this one, we have a state of stress. We have sigma x value is shown leftward, that equal to 10 megapascal. Sigma y is shown outward, that equal to 50 megapascal, and we have shear stress is equal to 40 megapascal. So read this value. We have sigma x will be compression, will be taken as minus 10 megapascal. We have sigma y is tension, is taken as positive 50, and we have tau xy. Since this one is a right phase and it is going upward, so we'll take it as a positive value. This one is a positive phase and going upward, that is the positive of y is positive. This one is also positive phase and going to the positive of x-axis, so is taken as positive value. So from this, the coordinate of center will be equal to, that is the value of sigma average. Sigma average will be same as equal to sigma x plus sigma y divided by 2. In this case, we have to take the value of sigma x is minus 10, sigma y is equal to 50 divided by 2. So minus 10 plus 50 is 40. 40 divided by 2 will be equal to 20 megapascal. And the radius we can calculate using the shear stress formula. That will be same as under root of sigma x minus sigma y divided by 2. And you have to make a square of it. Plus we have tau x y square. And everything in the under root sign. So this value will be same as equal to under root of, we have sigma x equal to minus 10, sigma y equal to 50. So we have minus 10 minus 50 divided by 2, and we have to make a square of it. Plus we have shear stress is equal to 40. So we have 40 square. Numerator here is 60. 60 divided by 2 is 30. 30 square plus 40 square. So in this case, we will get a radius equal to 50 megapascal. So with the average value, we can locate the center, and using the radius, you have to draw the circle with radius equal to 50 megapascal. So this one is a sigma value, that is the normal stress. This one is a shear stress, and we have center at 20 megapascals. So approximately here we have sigma average equal to 20. This one is same as our point O. So O represents the center at sigma equal to 20, and we have radius of the Mohr circle is equal to 50. So 20 plus 50, so this value will be same as equal to sigma average plus tau max, that will be equal to sigma max equal to 20 plus 50 is equal to 70. This value is the average and we are going on the left hand side, so this point will represent the sigma average and you have to subtract the value of tau max. So this value represents the sigma minimum. In this case we have sigma average equal to 20 and the shear stress equal to 50. So this value will correspond to minus 30. Or we can obtain the same result from calculation also, that is sigma max equal to sigma average plus tau max and sigma minimum equal to sigma average minus tau max. Now to find out the principal plane angle here, that is the most important thing, you have to first record the value of x phase. So our x coordinate will be equal to, this value of sigma is negative, is minus 10, and the rotation of 40 megapascal about the point O is anti-clockwise, so that will be negative value, is minus 40. So from this point here you have to go negative minus 10. So negative minus 10 will be somewhere here because already recorded this value equal to minus 30. This value we have recorded equal to plus 70. Center we have recorded equal to 20. So minus 10 and minus 40. So we can record the point x on the graph somewhere here, where we have sigma x equal to minus 10 and tau xy will be equal to minus 40. So this point represent our x phase. Similarly, we can record the y phase coordinate. For y phase coordinate, sigma y is positive value is equal to 50 and the rotation of the shear stress about the point O is clockwise, that is taken as positive value. Now sigma x is 50, that will be less than 70, so somewhere here we have 50 and tau xy same as 40, so we have 50 and this is our y phase. If you want to find out principal plane, then turn this by an angle equal to 2 times of theta p such that y will overlap on sigma axis. So we can calculate this angle of 2 times of theta p. For this one, this value is 50 and 20. So we have this base is 50 minus 20. 50 minus 20 will be equal to 30. And the vertical height will be same as equal to 40. So in this right angle triangle, this value is same as 2 theta p. Base is equal to 30 and the height is equal to 40. So we can very well calculate the principal plane angle. 2 times of theta p is equal to opposite is 40 and the adjacent equal to 30. So you can very well solve this. Now here we'll discuss the 3 standard cases of a Mohr circle which are important to find out the maximum principal stress and the maximum shear stress, as we required this idea in the case of maximum normal stress theory and the maximum shear stress theory. Case 1, let's consider here that we have sigma A and sigma B are the 2 principal stresses and value of sigma A is less than 0 as well as the value of sigma B is also less than 0, and let assume the sigma A is lower than the value of sigma B. Say for example we have sigma A is equal to minus 70, sigma B is equal to minus 40, sigma A value less than 0, sigma B is also less than 0 and minus 70 is less than minus 40. So we want to show here the Mohr circle with the 2 known value of principal stresses. Both the value are negative value. So one value of the principal stress is minus 70 and second value is equal to minus 40. Since we are knowing the principal stresses, we can very quickly draw the Mohr circle passing through these 2 principal stresses. So this one is origin at 0, then we have minus 40, that is the value corresponds to sigma B, and this value is minus 70. So this value corresponds to sigma A, this value corresponds to sigma B. You have to draw here a Mohr circle which will pass through minus 70 and minus 40. So this one is representing the Mohr circle and the diameter of the Mohr circle will be same as equal to the distance between sigma and sigma B is 70 minus 40, that equal to 30. And therefore we have a radius which will represent the tau max. So the tau max value will be equal to the radius. and we have radius is same as equal to 15, is same as equal to tau max. So we know the principal stresses and the value of the shear stress. So when both the principal stresses are negative, the Mohr circle will lie to the left hand side of the shear stress axis. Second case, we'll take one value of the principal stress as positive and second value is negative. So let's assume here that the value of sigma A is less than 0, sigma B is greater than 0. Naturally here, the value of sigma B is positive will be greater than sigma A. Or we can take example as sigma A equal to minus 30, sigma B is equal to plus 40. So on the sigma axis, you have to plot both the value of sigma A and sigma B. This time sigma B is a positive value. So somewhere this one is positive 40 is value of sigma B. And sigma A you have to plot on the left hand side. So this one is the value of sigma A. That will be equal to minus 30. Diameter will be the distance here from sigma A to sigma B, that equal to 40 plus 30. So this time we have diameter will be equal to 70. So radius will be same as equal to tau max is equal to 70 divided by 2. That will be equal to 35. One maximum normal stress is positive and second is negative. The Mohr circle will lie on both sides. So while we are discussing this, I want to discuss here one more concept. This one is called as the maximum shear stress in plane. And here we have the maximum shear stress in plane will be equal to 35. Another concept used is using the 3 Mohr circle. That is, for 3-dimensional state of a stress, you have to draw the 3 Mohr circle, and for that one you have to calculate the absolute value of the shear stress. That is the value of tau max. This value is tau max is for plane shear. So let's consider here the third case. In the third case, we'll take both value, that is the principal stress sigma A is greater than 0 as well as sigma B is greater than 0. So both are positive value, and again we assume the value of sigma B is greater than sigma A. So we can take example of sigma A is equal to 30, sigma B is equal to 80. So 80 is greater than 30. This time we have principal stress is 30. So let's mark this point. This value is same as equal to 30 is sigma A. Other value is equal to 80. So this value will be approximately equal to 80, and this one is same as sigma B. Draw one circle passing through sigma A and sigma B. That will be the Mohr circle. So in this case, we have diameter is this distance, which is 80 minus 30 equal to 50 megapascal, and the radius is half, and the radius is same as tau max is equal to 50 divided by 2, that equal to 25. So every time your value of the tau max will change. In the first case, we have the Mohr circle will entirely lie to the left hand side. In the case number 3, Mohr circle will lie entirely on the right hand side. And for case number 2, when we have two different value of sigma A and sigma B, one is positive and other is negative, then it will lie on both sides. This value of the tau max is called as the maximum shear stress in a plane. Other concept we'll use is the absolute value of the maximum shear. That is, we can do using the 3 Mohr circle. That value we can find out by drawing the 3 Mohr circle and converting the plane stress into 3-dimensional stress. That we'll discuss in the next video. The video you are watching is from the app, which is the Mohr class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.